Hello all, welcome to Ambari Cloud YouTube channel, part of Ambari Cloud LLM ebook videos. Today I'm going to discuss VectorDB in this video. Then we're going to practice on Milvus VectorDB, and also we're going to practice on the Postgres VectorDB. Okay, so why we need VectorDB and what is it, and then how the search works, how the data being stored. Those steps we're going to practice, but before that we're going to discuss what is a VectorDB. So in traditional databases, we have a tables and columns and data is stored, but it is mostly the text data, then JSON, maybe variant columns, PDFs. Now to store vector data, so if you look at in our previous videos, we learned about embedding, and then it generates a multi-dimensional vectors, right? So for example, when we use the Milvus, long chain PDF reader, it creates a 1536 size embeddings as is shown in this here. But we need to store these embeddings, and then once we store it, create a multi-dimensional space, then related documents stay together, search and nearby search and all the stuff. So it's a specialized database designed to store, manage, and query data represents as a vector in high dimensional space. Right? And the vector dimension can be various, depends on the model, but the bigger, more accurate, smaller, less accurate, of course. And these vectors are typically generated through embeddings. We saw that one in the previous videos. We use OpenAI embeddings. And then vectors can be text, image, audio, video. But as of now, we practice only text or PDFs. So, transform into numeric array that encodes into meaningful features, right? So high dimensional storage, right? We can convert raw text into vectors, and then we're going to store in a matrix format. And then it allows you to do similarity search. There are different similarity search: Euclidean distance, inner product, L1, L2s they call. And so part of this class, I'm not teaching what is L1, L2 or what is Euclidean distance and cosine similarities. But I will set up a separate video. It's part of ML class. Then, learning about those mathematics, it also helps you, right? And then if you want to store massive data, right? Because if you have thousands of documents and then, you definitely need a vector store. Then it has a built-in index mechanism. When you store, it automatically, based on your index requirements, it automatically builds an index. So that way then search is easier, right? Then, it allows you to do a lot of machine learning, then, natural language processing pipelines, you can use it. And also, you can do in, different search, as I said, Euclidean similarity search, all the stuff. Okay. So why we use vector? Of course, semantic search, right? Similar data. If you store the vector, then we can retrieve similar data easily. And then generally it is used for recommendation system, like, related data together, right? Clustering. Then, if you look at here, clustering and categorization, right? So bring the all together group, right? So then, so semantic search, related data nearby, and that way then we can do grouping of them. Common use cases with, test search, right? So particularly when you are part of using LLM through long chain APIs, so it's easy to search based on your query requirement, send that text to LLM, then, we can get answers. And for example, you want to summarize. So we're going to send all the documents from vector store to LLM, then LLM will sum. Then you can also do similar pictures, right? If you store, then we can, related pictures, because similar pictures will have similar vector space. Then, there are anomaly detection. Okay, if a product is not within a particular, if a text or image not within the product, within the cluster distance, then if it is away from the centroid, then, you can do anomalies and those things. You can do that. I'm using the word centroid, L1, cosine, in Euclidean distance. Those are, learn those, what is the actual meaning of those and how they are constructed. But within the domain of the vector store, just remember those words, but you don't have to deep dive. But, it's better to learn. What are the popular vector stores? So FAISS, it's mostly we use right now for memory base. Then Milvus is more popular too. And then I have not used Pinecone, then Chrome and others, but the PG Vector is also common. The reason PG Vector is common is many organizations use Postgres as the database in production in all environments. Now, if you add a PG Vector extension, then you don't have to spend extra money and then extra skills learning because it's there and the data stored in the tabular format. And of course, PG Vector, in the vector Postgres database, it builds your indexing. Okay. So in our class, in our videos, we're going to discuss about Milvus. We're going to discuss about PG Vector, then step by step how to start the Docker container Milvus on your on-prem, and cloud. You can do managed service. PG Vector, we install PG Vector connector then to the Postgres database, and we're going to use a Docker for also that. So basically to build retrieve, basically that means we need to store all our data in a vector store. So the RAG are for retrieve, right? Before retrieve, right, you need to store. That means you need to build indexes, and you need to understand what is index and what is a collection index, right? And then how to configure Milvus and Postgres and look at the data. So those skills you needed. And also you want to add new documents, or you want to delete existing document, and you want to find what documents exist. Then you want to delete and insert a document, right? Upsert. So those things you need to practice before you build your vector store pipeline, right? So the vector store pipeline is an essential part of your RAG architecture or agentic architecture. So make sure that you learn, and we will also practice end-to-end part of our agentic design. So basically you have a documents, and then you're going to embed, you're going to read it, chunk it, overlap it, embed it, store it. Then while store it, you define your vector store indexes or collection definitions. Then you should know how to read and delete and find all those things. Then we will be ready for the generative part of it, right? Then we will learn about ChatGPT, right, LLMs, and then how to create messages, system message, AI message, and then human message and all that stuff. So that's how we need to make sure we have to have a full understanding, full practice of vector store. As I said, vector store, efficient search similarities. Now the Elasticsearch also supports the vector store. So along with key value pair search. So, and efficient similarity search in high dimensional space, then scalable for massive data state, and also is flexible for multimodal data, text, images, and all the stuff. Okay. How it works, right? As I said, prepare the data. So you're going to create a documents. In order to create the documents, you load the documents, then you split into pages, you split into chunks, and then overlap it. Then you create embeddings, and then you store the embeddings into a collection, right? And then that's basically data preparation, and then you store into a collection. Then after that, you query it. You can do direct query using vector store APIs or Postgres SQL. Then you send this information to your LLM. But now with long chain API, everything is built in. You don't have to do a low level API learning, but in understanding it helps you, right? Particularly if you are defining your vector stores, you are part of your vector pipeline. And then once you query, then your query is also converted into embedding, and then do a similarity search. It's a built-in functions, and then you get the result. This result will be sent to LLM, and the LLM will generate your request. Okay. So this is how the introduction. In another video, I deep dive on the Postgres. Okay. Thank you. Any questions, reach out to me, S. Kondapalli at ambaricloud.com. Thank you.